Okay, hopefully you put away all of your chalk and your chalkboard so your mom is not going crazy with having all the schoolwork lying around. And if you have the Life on Surtsey book, you can get that out. And we'll read. If you didn't watch the last video, you do need to go back to the previous email and watch the last video of me reading, because I'm going to begin where I left off there, and you will have missed a whole bunch of stuff, especially about two very special birds from the island. So if you haven't watched the previous video, pause this one, go and look at the previous video, watch that one, and then you can come back to this one. Okay, so now that you have watched that video, I want you to tell someone what you learned in that video. So pause again and tell somebody two interesting things that you learned from the last reading. Okay, so this week we're actually going to start out by reading a lupine is a lupine. Is a lupine, or is it? So this is on page 14, and you'll have to see as we finish reading it, you'll have to tell me in your email, if you started one, what a lupine is when we get to the end of it. So here's what my book says right there, and I'll begin reading on page 14. Scientists have been using a two-name binomial system to name and classify organisms since Carl Linnaeus first suggested the idea in 1753. The system uses Latin words to describe the genus and species of an organism. It helps avoid the confusion that arises when people in far-flung regions of the world call the same organism by different names, or different organisms by the same name. For example, lupine is what Icelanders call the invasive purple flower that blooms across the country in midsummer. Although a related plant grows in the northeastern United States, and even though gardeners there also call it lupine, the two plants are not the same. The Icelandic plant is Lupinus nootkattensis, imported from Alaska, and the New England plant is Lupinus polyphyllus. In this book, organisms are mostly identified by the names commonly used in Iceland. In cases where organisms are shown in photographs, both the common name and the Latin binomial are provided in the caption. So, is a lupine a lupine a lupine? And what is a lupine? You can answer that question in the email to me. Also, if you did not get a chance to watch the video on Carl Linnaeus' system, go ahead and pause the video and you can go watch that video that I sent. Click on the link for that and then come back to this video. So we're going to begin on page 19 in the book, and it's talking about growth. And I wonder what kind of growth they're going to be talking about. You can judge for yourself. So here are the two pictures that are on these pages. There is Surtsey, and gosh, it does look like it's grown, hasn't it? Not just in size, but also the things that are on the island. You can even see some of the things that are growing on there. And then here are some of the scientists, and we'll read about them. Okay, let's begin on page 20. It takes a four-bladed, twin-engine rescue helicopter 2 trips to get the 2015 Surtsey expedition. 8 scientists and 2 observers, plus equipment and food for 1 week, safely to the island. Erling travels with the first group, a camera hanging over his inflatable vest jacket. Every flight over Surtsey offers him a rare opportunity to photograph and later, back at home, more closely study Surtsey's tall lava cliffs and the birds that live there. So before takeoff, Erling reminds the pilot to fly at least 1 full circle around the island before landing. Most years, Erling can take the photos he needs through the helicopter window, but today, however, it's raining. Visibility through the small rectangle of glass at the back of the helicopter is terrible, but the crew knows how important flyover images are to Erling's work. So when Surtsey comes into view, one of them waves him forward. The roar of helicopter blades and engines is much too loud to hear anyone talking. Erling makes his way to the center of the aircraft, where he is fitted into a harness. Securely tethered, he sits cross-legged on the floor between a pile of gear and the door of the helicopter. He adjusts his baseball cap, tightens his grip on the camera, flashes a thumbs up to the crewman. The door in front of him slides open, and he lifts his camera and starts to shoot. Through the open door, everyone on board can see the birds, the tall black cliffs they call home, the froth of ocean waves smashing into the base of those cliffs. Damon? Sorry, little interruption. And when the angle of the helicopter is just right, the entire expanse of the island they are coming to monitor. Most of Surtsey's edges are sheer cliff faces. In some places, these cliffs stretch more than 40 feet, 13 meters, or about as high as a school bus is long, up from the surface of the ocean. Even though they are coated with lava, the pounding of the northern Atlantic challenges these cliffs constantly, reshaping the island on one crashing cliff side at a time. The exception is Surtsey's northern shore, which slopes gradually to a low, rocky beach, a spit of land that points back toward the mainland. Wind and waves change the shape of the spit drastically each winter. This year, it looks remarkably like the tiny arm of Massachusetts known as Cape Cod. Two mountainous ridges rise from the middle and the western edge of the island. These are Osterbunky and Vesterbunky, remnants of tephra cones that built up around the islands that formed Surtsey. Osterbunky and Vesterbunky mean eastern cone and western cone in English. Their surfaces are lighter in color than the rest of the island and marked with erosion lines. Beside the ridges are the volcanic craters. Okay, so I'm going to go ahead and just hold this up and see if you see some of those things he's talking about. So do you see, we can't see on this side the beach, but we can see some of the cones and the craters that he's talking about. Surtur, the smaller crater, sits beside Osterbunky, and Surtungur, the largest, sits beside Vesterbunky. Spreading out from the non-ridged side of each crater, stretching to the southern and eastern edges of the island, is a large field of black lava. And in the very center of the lava is an unexpected splash of lush green plant life. This is the gull colony, home to hundreds of nesting lesser black-backed gulls, greater black-backed gulls, and herring gulls. Even from a helicopter, one can tell that this oasis is the center of life on Surtsey. When Erling had finished taking pictures, a crewman closes the helicopter door and the pilot turns toward another speck of color, the red roof of the research hut. He lands gently in the middle of a tiny cement landing pad right next to the hut, and things immediately get busy. So I want you to pause this just a moment and tell me one thing that you learned concerning the description of the island. And here, can you tell where the red hut is? Hopefully you can see it. The door slides open again and passengers hop out, Erling first and then several others. Crewmen toss gear through the door, 2 and 3 items at a time. The scientists trying to keep up, handing each box or bag or suitcase from one person to another until the last in line drops it into the chunky black sand. Within minutes, the helicopter is aloft again, this time heading to the nearby island of Himeji, where the rest of the 2015 Surtsey expedition team is waiting for a lift to the island. Surtsey is as beautiful as it is otherworldly. In all directions, the view is of black sand, deep ebony today because of the rain, and lava rocks in black and rust. Here and there around the lava sculptures are mounds of green tufts and tufts of brown grass. The only man-made structure in sight is the research hut. Whiffs of steam creep low over the ridge's textured surface, a gentle reminder that the researchers are unpacking at the base of a sleeping volcano. Here's a picture of the helicopter. Everyone on this year's team has worked on CERTSI before, so none of them is distracted by this particular land state. Instead, they haul plastic bins of food, backpacks, sleeping bags, and suitcases from the pile next to the landing pad up onto the porch of the research hut. Erling pulls a long metal pole from underneath the hut and uses it to open the wooden shutters locked over the windows. Matthias, an entomology student who has come to monitor insect life with Erling, begins moving luggage and supplies into the hut, and Lavisa, a geologist, help him. Powell, a botanist, finds a shovel under the hut and starts digging a hole in the sand near the porch. This makeshift refrigerator will keep the team's perishable foods cool for the week. Erling and the others finish their moving in chores just as the second half of the 2015 expedition team arrives. Borgpur, Sigurdur Bajarni, and Kristjan are all scientists, and Bordis is a representative from Iceland's Environment Agency. They too have been to CERTSI before. They unload their gear straight away, paying little attention to the scenery or the steady drizzle. So here's a close-up picture of the hut. In the early years of the island's life, which were also the early years of Erling's career as a professional entomologist, he came here irregularly. In the decade that followed his first 2 summers here, he was able to get to CERTSI himself only 3 times. A day in 1976, a week in 1981, and another day in 1984. He was always convinced, however, that regular sampling of insects was critical to telling CERTSI's life story. He worked constantly to secure funding and a position on CERTSI expeditions. Since 2002, he's managed to spend 1 week on the island every single summer. And when you have only 1 work week, 5 days in all, to assess all the changes that have taken place on an entire island over the course of a year, you can't let rain deter you. By the time the second team has hauled their gear into the hut, Erling and Matthias have assembled the tools they'll need to start trapping insects. Packs on their backs, nets in their hands, they head out into the wet sand. Here's a picture of them heading out. When scientists began tracking the various forms of life arriving on CERTSI, it was clear they needed a system for keeping track of place on the island. Geologic features were obvious landmarks. The ridges of Osterbunki and Vesterbunki, for example, and the Surtur and Surtungur craters. Another way scientists keep track of location, however, is by overlaying the island with an imaginary grid, much like the system of latitude and longitude used to pinpoint locations on planet Earth. This grid allows researchers to keep an accurate record of exactly where they find certain plants or animals. 30 of the squares of this imaginary grid have been marked out in the sand on CERTSI with permanent wooden stakes, 1 pounded into each corner. Scientists monitor different aspects of each of these 30 squares during every expedition. Botanists keep track of the plant life in each plot. Other scientists record the presence of fungi or birds' nests or the nutritional composition of the sand. Erling monitors insect life. Today, he and Matthias will begin that work by setting pitfall traps in the heart of each of the 30 10-meter by 10-meter square plots. And here's a picture. And I'll tell you a little bit more about this picture and what you can do at home to be a scientist like they are, just in your own backyard. So I want you to pause the video and just talk a little bit about how they prepared for their work, and then some of the things that they were doing in order to graph their information, get their information written down and organized. Okay, so one of the things that you can do besides the science experiment, which I sent in the email for you to look at and work on in your own yard, you'll only need a notebook and a magnifying glass to do. You can do it work on this experiment in your yard, and then the next week you're going to go to a different location, and the next week you're going to go to a different location. And that sounds difficult, but if your family has been going to parks or other areas to take walks, just choose some of those areas to go to. Or you can even do like front yard, backyard, because we have very different things going on in our front and our backyard. We also have some woods right behind our house and the pine grove right at the end of our house, and we have pond life at the other end of our street. So there's all kinds of options real close to where you are, I'm sure, to be able to do this experiment in 3 different areas over the next three weeks. But the another thing that you can do, just like these scientists are doing, is to dig a little hole and to put a cup in it, and to fill it with a little bit of alcohol, and you'll see what kind of animals, insect life, lives in this little area. And you can even measure like 1 foot square, which is 1 foot on one side, 1 foot on another side, 1 foot on another side, 1 foot on another side. That's 1 foot square, and put the cup in the middle of the square, dug mostly into the dirt, but a little bit of ridge up, and you can read about it in the book. They'll tell you what they did, and you can see what kind of insects will come. They talk about using formaldehyde. You can use just straight up alcohol. That'll work pretty much the same way. We're not trying to preserve them, which is what the formaldehyde would do. It would kill and preserve. You're just wanting to kill them so you can see the insects. But so we're about halfway finished with our book, and it's kind of exciting. And I really think this man, Mr. Erling, is very tenacious, persistent, and he really wants to study. I feel like it's the heart of a scientist, and I think we saw that from the time when he was a little kid. Think about when he was little and some of the things that might have encouraged and fostered this love for insects and botany in him. And hopefully you'll remember a couple of those instances. Until next week.